Hey everybody, for my hack week I worked on content addressing, but for real this time. So let's run through, how you might want to interact with a content address system. So here I am, checked out Powershell, its tool, and I want to go download it. And I could download the file, I guess, from GitHub. Well, maybe it's having problems or it's slow, but I noticed that this whole thing has hashes, and I hear IPFS does hashes. So let's just try something out, just see what happens, right? Maybe I'll do IPFS get. This is a SHA-256 hash, so I'll add in the magic bytes that say it's a hex CIDV1 file that is SHA-256. And let's see what happens. All right, found it. That's pretty cool. And this is particularly cool because I didn't contact anyone at Microsoft and ask them can you please upload your files to IPFS or have IPFS hashes or anything like that, right? The power is in the hands of the users. There happened to be another user who added this file, and then I looked for it and it was there. And this concept is really powerful, right? Whether it's, if you look at Andrew Nesbitt's Forest Package Manager demo, which is super solid, I highly recommend checking it out. He's able to download packages from NPM or Go packages just based on their hashes. It works most of the time because most of these programming language packages happen to be less than 1 megabyte, which is the max we can deal with. But for bigger files, it would be really cool to do that too. You could do things, see, like sub-resource integrity in browsers. There's hashes there. Okay, we could cache all that data. We could find it over IPFS. Gateways are verifiable because when you get sent file data, you could then confirm that the data matches what you expected, which is pretty cool, right? So back to content addressing for a little bit. When we talk about content addressing, we tend to say content equals address, right? Which is obviously false, because if the address was the same as the content, then by the time I told you about the address, I would have told you about the whole content, which makes it not very useful. So really, we tend to mean that the address is like some sort of fingerprint of the content, right? Something that is representative enough of the content that it's unique. So if you've used IPFS in the past and you've looked at the IPFS add help command, you may have noticed a million flags. You can change the chunker. It can be 256 kilobytes or 512 kilobytes or a megabyte. Or it can be, you can use a content-based chunker like Robin or BuzzHash, or you can have you can have protobuf wrapped leaves or raw leaves, or any number of, you can change the internal hashes of the leaves of the intermediate nodes inside the file. There's a lot of options. But what we'd really like to do, we see the benefit, is that we're going to take a file and we're going to have basically one address for it, right? And you can't do this for everything. There is no single format in the world that describes citizenship records. Every country's got their own. Every municipality and district probably has their own for dealing with their members. But for files, there is a canonical representation. You just take all the bytes and you put them one right next to the other, and that's the representation of the file. And people have been running, programs like SHA-256 sum on their files and generating hashes and putting them online for a long time. So we can do this. And we can even expand and cover a few different hash functions, SHA-1, SHA-2, SHA-3. We can do those. But it's there's a very fixed number of ways to describe this file. So why isn't this already in IPFS? Basically, we download blocks of data, right? Content address blocks of data in IPFS, right? The graphs are made up of blocks. And there is a set limit of a maximum block size that's about a megabyte. So why not more? More means that you sort of you're unable to download things in parallel. Imagine we have, I download my 100 megabyte file from two people, and one of them gives me bad data. I don't know who gave it to me, because all I know is that when I combine the bytes together, they don't match what I'm expecting, but I don't know who lied. Right, so this means I can't do anything in parallel. So that's sad, right? If the files if I'm just treat my 100 megabyte file as a single block, that's sad. And the other is I may not, like, the files could be humongous, or I might not even know in advance how large they are. And so I could go and I could be downloading 1.2 terabytes of data, and then I find out it's not the data I was looking for. And while I'm not going to get tricked into like using or running the data, I've also used up all of Comcast's 1.2 terabyte data limit, and now I'm basically kicked off the internet, and that's pretty bad too. And so we have the lesser of the two evils, this 1 megabyte maximum block size. So what's the magic? How to get this to work? Basically, hash functions work on small bits of data for the most part. And so what we take advantage of in a function, say like SHA-2, is that the function is linear, which basically means that the hash function, sort of like Pac-Man, just goes and like eats the bytes one at a time, right? And sort of, it's like every time it eats a new byte, it like changes color. It goes like, yellow and then blue and then red. And all you get is the state at the end, which is maybe like red Pac-Man. So you say, all right, let me try downloading. So what we're going to do is we're going to download the file backwards, because we know that that Pac-Man had to transition from blue to red. So if someone tells us the intermediate hash, right, the blue Pac-Man and the data, we can use it to get the red one. So now we've actually broken up our hash of a huge file into a bunch of smaller hashes, sort of going a little bit back at a time. Which is enough for us to sort of circumvent these problems we had earlier. We got a bonus benefit from all of this, which is IPFS can actually transport any IPLD DAG. So we say this, we like this, we want it to be true. But if somebody made a file format and ignored IPFS's 1 megabyte block limit, or they made the file format before the existence of IPFS, like Git, it's possible that they have blocks that are content addressed that are bigger than 1 megabyte, and then we just can't transfer them. And now we can. So that's pretty awesome. Thank you to everybody who's helped me put this together and think about this and work through this over the last month or so. There's more info. Reach out if you've got any more questions, want to talk more about this. And if you think this is super cool, then A, check out Andrew's demo. You're really going to like that one. And B, encourage work to keep going on this, because there's a lot of ironing out the details before this gets its way into to IPFS. I'll be pushing on it.